Welcome back, cadets, to Mission 002. I'm Professor L, and in today's explainer, we're going to completely break down Worksheet 1A. We're going to make it so incredibly simple, you'll breeze right through it without a single drop of stress. So, grab your pen, open up your workbook, and let's transform you from students who just guess at the answers into junior engineers who actually solve real-world problems.
Most people will just rush to answer a question the second they recognize a familiar word on the page. But cadets, engineers do not guess, they investigate. Before we write down a single word today, we need to lock in our core tactical mindset. We are going to become detectives first and builders second.
And to pull that off, we're going to use my absolute favorite secret weapon, Professor L's full marks formula. This 6-step sequence is literally a cheat code to guarantee maximum points on every single question we tackle. Okay, here's how it works. First, you read the question twice. Second, you circle the command word, like what is the examiner actually asking you to do? Third, underline those key words. Fourth, take a second to actually think before you write. Fifth, use your proper technology vocabulary. And finally, always answer in full sentences unless they tell you otherwise. Stick to this, and honestly, you'll start doing it completely automatically.
All right, let's dive into our briefing. Here's the exact scenario we're dealing with, broken down so simply a 5-year-old could get it. The Siakanya Community Hub is this super important safe space where over 150 learners go every single day to study and use the computers. But recently, disaster struck. Intruders broke in, really valuable equipment, including laptops and a projector, was completely stolen, and things were even set on fire. Because of all this destruction, the hub had to close its doors. The learners lost their safe study space. So, your mission as a junior engineer is to build a safety device prototype to make sure this never, ever happens again.
Let's hit questions 1.1 and 1.2. You've got two options for your project. Option 1 is a security alarm system that spots intruders by sensing light. Option 2 is a fire alarm that detects a fire by sensing heat. First up, for 1.1, you just need to pick one of those options and state it clearly. Then, for 1.2, you have to define the exact problem that your specific choice is trying to solve. What exactly went wrong, and why does fixing it matter so much?
Now watch out for this trap. A student who's just rushing through might write something like, things were stolen. But a junior engineer using our full marks formula, they're going to build a complete sentence that paints the whole picture. You want to write something closer to, the hub lost valuable equipment to theft and fire, causing it to close and leaving learners without a safe study space. See the difference there? We defined exactly what went wrong, and we explained why it actually matters to the community. Boom, full marks.
Moving right along to question 1.3. This one asks why a security system is important for community spaces like the hub. Now, what the examiner is really digging for here is your reasoned opinion on why spaces like this need active protection. Just ask yourself, what happens to the kids if the hub stays completely unsafe?
To absolutely lock in your full marks, you're going to take 3 key points and smash them together into one incredibly strong sentence. Point 1, it protects valuable property. Point 2, it prevents crime. And point 3, it keeps people safe so the doors can stay open. Put it all together and you get, a security system is important because it protects valuable equipment like laptops, keeps the space safe for learners, and prevents the hub from being closed down. Nail that, and you're golden.
Okay, question 1.4. We're going to divide and conquer this one, because engineers love breaking big, messy problems into smaller, manageable ones. First, we need to scan our briefing to find the 2 specific disasters this community faced. Let's go back and investigate that background text.
See, the text literally hands us the answers. That's exactly why we investigate. Challenge 1. Equipment, specifically laptops and a projector, was stolen. Challenge 2. Property was set on fire and vandalized. Just underline those in your text, write them out clearly, and you've already crushed the first part of the question.
Now, for the second half of 1.4. Why are early warning systems so important? Well, think of an early warning system kind of like a friend who yells out, "Hey, watch out," right before something terrible happens. Why is that helpful? Because it buys you time. You need to explain that early warnings give people that crucial split second to react, to call for help, to notify security, or to grab an extinguisher before a fire spreads out of control.
All right, let's look at question 1.5. Real engineers always look at existing real-world examples before they try designing anything new. The question wants one example of an alarm system and one example of a fire alert system. So, just think about your daily life. Look around your neighborhood or your school. What flashes or beeps around you? This one's actually pretty fun. For an alarm system, you could totally just say a car alarm, or maybe a house burglar alarm with one of those beeping keypads by the door. For a fire alert system, think of that little plastic smoke detector on your ceiling that aggressively beeps when it senses smoke, or even the loud fire bell in your school hallway. Just write down one of those everyday examples for each category, and you're done.
We have made it to the final boss of Worksheet 1A, question 1.6. Now, I know this looks like a massive, intimidating table, but I promise it's just a simple sorting game. We have to categorize the components for 4 everyday things: a kettle, a hairdryer, a lamp, and a drill. We just need to toss the parts into an electrical box or an electronic box.
To make this completely foolproof, just memorize this one rule. The electrical side, that's the basic, brawny stuff. It's the natural sciences side that actually powers the device. Think wires, heating elements, big motors. The electronic side, that's the smart stuff. The technology side that acts as the brain, telling it what to do, like switches, sensors, and circuit boards. So remember, electrical powers it, electronic controls it.
Let's put that rule to work. Take the kettle. The electrical part that physically heats up the water is the heating element. The electronic part that smartly clicks it off when it's boiling, that's the thermostat or switch. For the hairdryer, the electrical muscle comes from the motor and heating coil, but that little slider switch controlling the speed and heat, that's electronic. The lamp relies on the light bulb and wiring for electrical power, but if you have a dimmer switch, that's your electronic control. And finally, the drill uses a big motor and a battery for electrical power, but the trigger that lets you control the speed is electronic. Use this breakdown as your guide, but hey, true engineers always verify with their own research.
And just like that, mission complete. Look at what you just did. You successfully analyzed a real-world problem. You didn't guess, you investigated. You identified practical solutions. You constructed full-mark sentences. And you totally decoded the difference between raw electrical power and smart electronic control. Seriously, give yourself a massive pat on the back. But our mission isn't entirely over yet. Take a quick breather, junior engineers, because next time we're taking this exact same investigative mindset and applying it to the mathematics. Think about it. A security system might sound amazing when you describe it, but can you mathematically prove that your circuits will actually work? We are going to crunch those numbers in our next explainer. Until then, Professor L, signing off.